Okay, now let's talk about section 1.2, quadratic equations. Focus, focus. What's going on? Let me write down more words. Quadratic. What's the problem? Okay. Quadratic equations. Uh, what is a quadratic equation? First, let's clear the definition. So a quadratic equation is an equation equivalent to one of the form ax squared plus bx and plus c equal to 0. Because we want to emphasize this is quadratic equation where a is not equal to 0. So this leading term cannot be 0. And a, b, c are real numbers. Okay? So this is the definition quadratic equation. Here, a, b, c are real numbers. They can be positive, negative. In front of those three letters, it's always positive sign. So for example, if we have 3x squared minus 5x and plus 6 equal to 0, then you should notice that a is equal to 3 and b, very important, this b is negative 5. A, b, c always include sign and c is 6. Okay, if you see subtraction minus 5x or minus 6, those coefficients a, b, c must contain that negative sign. That's an important thing because sometimes certain formulas depend on the a, b, c, and we have to clearly see what are the values of a, b, and the c. Okay, so very important. This b is not 5, it's negative 5 because we always need plus b times x. It's actually like this. 3x, this is a. 3x squared plus b times x, so b is negative 5 and plus c. Okay, so this is a, this is b, and this is c. Just be careful about this situation. And an equation in such form like this, such form is said to be in standard form. To be in standard form. So many formulas depend on the standard form. Okay? And also quadratic, the highest degree is 2. So quadratic equations are also called a second degree equation. No, not A. Quadratic equations are also called second degree equations. Okay, just because here is a second degree. And a linear equation, they will say the first degree linear equation or first order linear equation, right? This is linear. first degree equation. So we start from first degree and we get a second degree. Okay. Second degree equation. Let's see the example. We see several examples. The first part, solve a quadratic equation by factoring solve a quadratic equation by factoring. Okay. Example. Okay, so solve the equation A if this C is not 0. Okay, so let's see the example. In this example, C is equal to 0. This represents a large class of a quadratic equation. If C happens to be 0, then what do we do? X squared plus 6x equal to 0. X squared, 6x, they have the common factor x. So you factor out x, you get x times x plus 6 equal to 0. Okay, part A. And then we have what? We have zero product property. What is zero product property? Yeah, let's cover it here. These AB are not that AB. A times B is 0, then either A0 or B0 or both are 0. Okay, so this is a zero product property. And here you have x times x plus 6 equal to 0. Then what do we get? Then by zero product property, we have either x is 0, first factor is 0, or the second factor is 0. Only when the right-hand side is 0, the product equal to 0, you have such property. If you have any other non-zero number, this property fails. Never apply it. Okay? Okay, x equal to 0, x is 0. X plus 6 equal to 0, so x is 6. X is 0, or x is negative 6, negative 6. Okay, so this is a solution set. The solution set is 0 or negative 6. There's no order to write solution set. You can write a negative 6, 0, 0, negative 6. Both fine. You just include both. That's enough. Okay. So when C is equal to 0, if you only have x squared term and x term, you always factor out x and then apply the zero product property. Zero product property. Okay? And second example, what is the second example? We have 2x squared equal x plus 3. Okay, this requires a factorization. Okay, this requires a factorization. So how do we factor it? First, we have to move all the terms to the left side. So we move all the terms to the left side. We move x to the left side minus x. Move 3 to the left side minus 3 equal to 0. 2x squared minus x minus 3 equal to 0. Then how do we factor this left-hand side? So here we have to try more examples and then we get experience. But the experience is the following. 2, you can write 2 as a product 1 times 2. 2 is a product 1 times 2. Negative 3 is a product negative 3 and 1. So you list those two factorization, okay? And then what you are going to do, you check that 2 times the opposite 1, negative 3 times opposite 1. 2 times 1 is 2. Negative 3 times 1 is negative 3. So you have two products. And then you add them equal to negative 1. And this number -1 is exactly the b. You see, b is -1. Be careful here. B is -1. Okay, when this happens, it means your factorization is good. So you can put x here and x here. So you will get 2x minus 3. You see, it's 2x minus 3. X, 1 times x is x. 1 times x, this is product. 1 times x, x. X, here nothing. Nothing means plus. X plus 1 is equal to 0. So this is a cross factorization. Okay? So 2x minus 3 times x plus 1 equal to 0. And again, we apply the zero product property. 2x minus 3, either 2x minus 3 is 0, or x plus 1 is 0. And both are linear equations, so you can easily solve it. 2x minus 3 is 0, 2x is equal to 3, or x 1 move to the right hand side is -1, 2x equal to 3, x is 3 halves, or x is -1, so you have two solutions. The solution set is 3 halves and -1, and that's it. Okay, that's it. Okay, so this factorization trick is very useful, but sometimes it's also very tricky. So you have to properly select the factorization. For example, let me give you more examples. Let me try to give you more examples from the exercise part. Where's the exercise? Okay, exercise part. Right, let's try. On page 101, exercise 38. Exercise 38. We have x squared plus 2/3 x minus 1/3 is equal to 0. We're trying to solve it by factoring. Again, I prefer integers if possible. So I'm going to multiply this equation by 3. I don't want the denominator 3. I multiply all terms by number 3. So it becomes 3x squared. Here, 3 cancel, you got 2x. And 1/3 times 3 is 1 minus 1. And then I'm going to see the factoring. 3 is 3 times 1. -1 is -1 times 1. And you try the cross multiplication. 3 times 1 is 3. 1 times -1 is -1. The addition of those two numbers is 2. So you see, that's exactly this number. When you match this b with this sum of two products, you are going to put x here, x here. Okay, 3x plus -1, so 3x minus 1. 1 times x is x, x plus 1. Okay, so that's a factorization step. After factorization step, you're going to apply zero product property. So you get x is 1/3 or x is -1. So the solution set is going to be 1/3 -1. Right? Okay, let's see next. Let me see if we can find another interesting one. Okay, let's see this one. Again, on page 101, problem 24. 2 times 2u squared minus 4u plus 3 equal to 0. All right, we're going to solve it by factoring. So first, let's write it in the standard form. So do multiplication, you get 4u squared minus 8u plus 3 equal to 0. 4u squared minus 8u plus 3 equal to 0. Okay, now let me try to factor it. 4, I'm going to write like 2 times 2. 2 times 2 is equal to 4. This is a product. Vertically is a product. And 3, I'm going to put a 3 and a 1. If this works, then what is this? What is a product? 2 times 1 is 2. 2 times 3 is 6, but sum is 8. We need a negative 8. Be careful here, we need a negative 8. So let's check. If we put negative 3 and a negative 1, why can we do that? Because we want the product of those two numbers is equal to 3. So if you put a negative 3, then you have to put a negative 1. So negative 3 times negative 1 is positive 3. And then this by this, 2 times negative 1 is negative 2. 2 times negative 3 is negative 6. Negative 6 plus negative 1 is negative 8. See, this is exactly the case. Okay, so sometimes you have to factor it in a smart way. It's very important. When this matches the b term, you're going to put a u here. This variable is u, so you put a u here and a u here. So you get 2u minus 3 times 2u minus 1 equal to 0. It has to be 0. And then you will get either u minus 3 equal to 0 or 2u minus 3 equal to 0 or 2u minus 1 is equal to 0. So u is a 3/2 or u is 1/2. So the solution set is 3/2 and 1/2. Okay, so this part about computation is tricky if you only want to use the factorization to solve it. But do more exercise. There are more recommended exercise in the practice part. Okay. Okay, so sometimes here you see when you have two solutions, they can be different, and sometimes they can be the same. Okay, so when the left side factors into two linear equations with the same solution, the quadratic equation is said to have a repeated solution. Repeated solution. Repeated because twice. The solution is also called a root of multiplicity 2. Or a double root. Okay. Okay, so you can see that repeated, you don't know how many times it repeats. So it's a very vague name. It's repeated. You can repeat it 10 times, repeat it 100 times, but still it's called repeated. And then the other two names are more precise. A root of multiplicity 2, so it means it's repeat twice. Or double root, double 2. If this is multiplicity 3, then it will be like a triple root, right? Or 4 times root, whatever. But these two names are more precise. Repeated are not that precise. Anyway, they just mean the situation. So let's see the example with repeated solution. Okay, solve the equation (9x squared minus 6x plus 1 equal to 0). 9x squared minus 6x plus 1 equal to 0. So 9, remember what we have done here. 9 solution. We factor 9 as 3 times 3. We factor 1 as 1 times 1. But after the cross multiplication, you will get 3 and 3 positive. Sum is 6. Unfortunately, here is negative 6. So you're going to put the negative sign, negative sign. Negative 1 times negative 1 is still positive 1. But negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. Okay, so it will be negative 6. Then now it fits. Okay, and once you fit this b term, you're going to put x with the first column. So 3x minus 1, 3x minus 1. Okay, you see it? And you have two identical linear equations. So you will get either 3x minus 1 is 0 or 3x minus 1 is 0. And this will imply x is 1/3 or x is 1/3. Okay, so the equation has a repeated root solution 1/3. A repeated solution 1/3. Okay, so that's the repeated case. A quadratic equation will have at the most 2 solutions. And here it has 1, even though you only write down 1, but it is repeated, so it's still 2. It's still 2. Right? So that's solving a quadratic equation by factoring. If you can factor it, then you will done like this. Okay? And second, square root method. What is the square root method? Assume we have b equal to 0. C is a negative number. You move c to the right side. Like, remember that ax squared plus bx plus c equal to 0. If b is equal to 0, then there's no middle term. You only have ax squared plus c equal to 0. And then I'm going to move c to the right side. I will get something more or less like this. You divide by a. We'll have x squared equal to something like this. Okay? So we assume this p is equal to this negative c over a. I don't know what p is the value of p. P can be positive, can be negative. Right? P can be positive, can be negative. P is this whole complex expression after simplification, whatever. Anyway, we start from here. If p is negative, there's no solution. Right? If p is negative, x squared is never a negative number, so no solution. If p is a positive, there are 2 different solutions. X is equal to square root of p, or x is equal to negative square root of p. So you will have a positive square root and a negative square root. Okay? If p is equal to 0, there is a repeated solution. We actually know what that repeated solution is. X equal to 0. If p is 0, x squared is 0, then x has to be 0. It's repeated. Either x equal to 0 or x is equal to 0. Okay? So we do have 3 different cases. 3 different cases. Less than 0, no solution. Greater than 0, 2 different solutions. Equal to 0, 1 repeated solution. And whenever you have some formula like this, and you follow these category cases to get some answer, this is called square root method. This whole process is called a square root method. Okay, so for example, if you directly have x squared equal to 4, then this will tell you x is positive square root of 4, which is 2, or x is negative square root of 4, which is negative 2. Right? So the solution set is two and a negative 2. And sometimes you can also write it like this. Plus minus 2. Plus minus 2 means there are two solutions. One is positive 2, one is negative 2. All right? So let's see the example. Example A, if you have x squared is equal to 5, then what is that? The x is a positive square root of 5 or x is negative square root of 5, because 5 is greater than 0. So the solution set is plus minus square root of 5. Write this symbol clear in the exam, plus or minus, PM. Okay? B. Part B, if x minus 2 parentheses square is equal to 16. So it's a little bit complex. Whatever inside, x minus 2, x plus 5, x whatever stuff, inside stuff squared is 16. So you reach this case, x squared, something squared is p. And this p is greater than 0, so there's two solutions. So either x minus 2, whatever inside, this x is a variable, it represents whatever inside, some complex or simple expressions. X minus 2 is positive square root of 16, which is 4, or x minus 2 is negative square root of 16, which is negative 4. Square root of 16 is always 4. With plus sign it's plus 4. With minus sign it's minus 4. Okay? So x minus 2 is equal to 4. Then x is 6. Or x minus 2 is negative 4. X is negative 2. You move negative 2 to the right side. It's plus 2. Negative 4 plus 2 is negative 2. So the solution set is negative 2 and 6. And that's it. So it's a very simple. Just follow the categories or cases and get 0 solution, 2 solution, 1 repeated solution. 3 cases. If you already have something squared equal to a positive number. All right. Okay, excellent. So we finished the lecture at this point. You must do the recommended exercise. If you have whatever question, just send me email and we can discuss it. And especially for this factorization trick, it's very tricky and it requires a lot of practices. Don't just watch the exercise. If you watch them, they look always reasonable. But once you do it by yourself, sometimes it's not just come for free. Okay? Then send me email if you have question. If I make whatever error, just let me know. Thank you very much.